So this is section 4.2 on trigonometric functions on the unit circle. So now we are going to be able to find trig values for angles that aren't just in a right triangle like we did in section 4.3. So what is the unit circle? Unit circle, it's a circle with a radius of 1. So you can think of like 1 unit. That's why it's called the unit circle. And each point on the edge of the circle corresponds to an XY point when placed on the coordinate plane. So once again, we are using the coordinate plane like how we used it when we were graphing our angles. Our unit circle, if we plotted it on a coordinate plane, these points we would know right off the bat. So 1, 0 would be here if our x is 1, y is 0, then 0, 1. So now our x is 0 and our y is 1, -1, 0, and 0, -1. And so there's going to be specific points all along the edge of this circle that are going to have some value and meaning to the trig functions. So let's take a look at what the important angle measures are in the unit circle and also the coordinate points that go with it. So all of these measures on the unit circle are the ones that you're going to need to know. So what I would do right now is pause this video and copy this down in your notebook. So at some point you are going to have to kind of know these, be able to recognize them. And the good thing about the unit circle is it does reflect. So if you know the first quadrant, you then in turn are able to kind of reflect that into the other quadrants. So just looking at the first quadrant here, the important angle measures are 0 and then 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So along with the degrees, we also want to know the radians. So you could go through and do the formula pi over 180 to get each of these radians, but I just give them to you right here. So 30 degrees is equal to pi over 6 radians, 45 is equal to pi over 4, 60 is equal to pi over 3, and then 90 is equal to pi over 2. And then as you go around the circle, I have all the degrees on the inside, and then you'll see that the radians are out here on the outside. So a couple things you might notice, these numbers in the parentheses, they show up. So like for instance, square root of 3 over 2 and 1/2, that's going to show up again over here, and then down here, and then over here. So all of these measures that go with the 30 degrees and the pi over 6, so all of the radians that are over 6 are going to have the same coordinate point, but depending what quadrant it's in will depend on what's negative and what's positive. So in the first quadrant, this is our positive quadrant. So that means both x and y are positive. In the second quadrant, so Q2, this is negative positive. So our x is now negative, our y is positive. So you'll see all the x are negative, all the y's are positive. Down here, this is our negative quadrant. So both are negative. And then over here, this is our positive negative quadrant. So you do need to know that. And if you just think logically about your XY axis, it's not too terrible. And then just knowing that it reflects. So here, this point is the same over here, is the same down here, is the same over here. So all of these, square root 3 over 2 comma 1/2, those are all going to be the ones closest to the x-axis. The square root of 4s are always the one in the middle, or not square, pi over 4s are always the one in the middle. So like square root of 2 over 2 and square root of 2 over 2. So you'll notice green, that one goes with green and green. So same point. And then all of the 1/2 comma square root 3 over 2, those are the ones that are closest to the y-axis. So here and here, and then down here and here. We're going to talk a little bit more about how to create this unit circle on your own. We're actually going to be doing that in class. But I do want you to have this written down in your notes. So if you just want to pause the video and copy that down. So moving on. So what is the point of having those XY points? Well, if we have any angle, so here we have theta again. So let theta be a real number. It represents an angle. And let XY be the point on the unit circle corresponding to, this should say theta. I'm just going to change that. So there's always a coordinate point that goes with your angle. So like, for example, if my angle is 30 degrees, this is the XY point. So this is X squared 3/2, this is Y, 1/2. If my angle theta is 60 degrees, this is my point. So there's always a point that goes with your angle. So whatever that point may be, sine of the angle is always equal to the Y value. So for example, sine of 30 would be equal to 1/2 because my angle is 30. Here's my point, sine is equal to the Y, so 1/2. Cosine of theta is always equal to the X. So in this case, cosine of 30 would be equal to the square root of 3/2. Um, and then tangent is always equal to Y divided by X. So in this case, it would be 1/2 divided by square root 3/2, and you would have to do keep change flip. So cosecant is going to be the flip of sine. So the definition technically is 1/y, but you can also do this. So like, for example, 1 divided by 1/2 is the same thing as 1 times 2/1. Keep, change, flip. So you can either just flip sine, which is 1/2, flip it to 2/1, or you can do more work by dividing it. Cosine still goes with secant, so you're just flipping whatever cosine is, and then cotangent is the flip of tangent, and that you can see, so x/y. So that is why this point, whatever those points are on the edge of the unit circle, why those are so important, because they tell us the 6 trig functions, right, from the xy point. So a couple different things you might see. So this is evaluating trig functions using the unit circle. So we're not going to be using calculators here. And I'll know if you're using a calculator because the calculator gives you decimals and all of your answers should be in fractions. So you'll see like here where it says find exact values, a repeating decimal is not an exact value, but a fraction is. So I'm looking for these numbers to be your answers when you do it out here. So it first says just find the coordinate point that correlates to each of the following angle measures. So here we have pi/3. So what you do is you go to the unit circle and you find pi/3, which is right here. So there's pi/3, and we're just going to write down that coordinate point. So 1/2, comma, square root 3/2. Because that's all it asks for. It just says find the coordinate point that correlates to each of the following angles. Here we have theta equals 0. So that is 0 right here. So the coordinate point would be 1, 0. So now when it says evaluate sine, cosine, and tangent at each of the real numbers, once again, this should say theta. At each of the real number theta, find exact values. So what this means is first we have to do this step, find the coordinate point, and then we have to use those definitions that were on the last page to write out each of the sine, cosine, and tangent for this angle. So 3 pi/4, if we go around our circle, here is 3 pi/4. So this is the point. So negative square root 2/2, comma, square root 2/2. So I would write down the point first. Keep in mind, this is x, this is y. So now, if we want to find sine of 3 pi/4, sine of that angle, sine, if we go back to our other page, is equal to y. So y is square root 2 over 2. So this equals the square root of 2 over 2. And you're done for sine. Then you have to do cosine. So cosine of 3 pi over 4 is equal to the x value. So the x value is negative square root 2 over 2. So your answer for cosine of 3 pi over 4 is negative square root 2 over 2. For tangent of 3 pi over 4, it is y, so sine, divided by x. So if you were to divide these two, so y is the square root of 2 over 2 divided by negative square root 2 over 2. If we keep the top, so square root 2 over 2, change this division bar to multiply, so times, and then flip the bottom, so 2 over negative square root 2. You'll notice that cancels, and we're just left with negative 1. So that would be the tangent of 3 pi over 4, would be negative 1. So cosine was negative square root 2 over 2, sine was square root 2 over 2, and tangent is negative 1. So we can now do the same thing for pi over 2. So for pi over 2, we're going to find the point right here, 0, 1. So sine of pi over 2 equals the y value, which is 1. Cosine of pi over 2 equals the x value, which is 0. And tangent equals y over x. If you have 0 in the denominator, that would be undefined. So undefined, you can simplify it like that. And that's it for the unit circle.